Hi everyone, welcome to Mr. Chin's class. Okay, so let's go over the part 2 of the practice internal. Okay, so in the question, it asked you to design a water bottle. Okay, and it told you that each time when you're taking a sip from the water bottle, you take about 10 cubic centimeters. Okay, and you know that, right? 1 cubic centimeter is equivalent to 1 milliliters, okay, and 1000 milliliter, that's equivalent to 1 liter. So that's the unit that you need to remember. Okay, and it said in the question, one water bottle should contain about 200 sips. Okay, so that was all the information that was given from the question, and it just asked you to design a water bottle of any shape except cubic. Okay, so let's have a look. So in order to contain 200 sips, okay, each time when you take a sip, it's 10 cubic centimeters. So the water bottle should contain 10 times 200 times 200 sips, and that's going to be 2000 cubic centimeter. Okay, and therefore using this units, we can change cubic centimeter into milliliters. Okay, so the bottle should contain about 2000 milliliters or about 2 liters. So it's quite a big container to be a water bottle. Okay, so you can design any shape, and this is one of my answers. Okay, for my first design, I made the water bottle into cylinder. So what I said is I'm going to let the radius of my cylinder shaped water bottle to be 5 centimeters, because if you think about it, if you let the radius of my water bottle to be like 15 centimeters, then what will be my diameter? Yeah, it'll be 30, wouldn't it? Yeah. 30 centimeters is the width of a your ruler, right? So it's going to be too wide to be a water bottle, correct? So you need to think about the realistic size of the water bottle and come up with a unit. Okay, one good idea would be get a cup or get a real water bottle and measure it, okay, and see what the diameter or the radius of a cup would be. Okay, so I let the water bottle to be 5, so therefore the radius is 5, so dimension of it will be 10 centimeter, so it's reasonable. Okay, and I wrote it down here. 10 centimeter width of the water bottle seems to be realistic size, so I'm happy with it. The base area is now a circle. Okay, so in order to find the volume and all the sizes, since I let this radius to be 5, the base area of my water bottle should be radius times pi, 5 pi. If I do that, I'll get that much for the base area. Now, you need to decide the depth of your water bottle, okay? But remember, consider the whole entire volume, okay, of my water bottle should be 2 liters or 2000 milliliter. Okay, so I said, and the water bottle should contain 2000 cubic centimeter, so the volume equation will be area times depth is equal to volume. Area we just calculated over here. Depth we haven't decided yet, but if I multiply them together, I should get 2000 as my volume. So I said I sent this to the other side. Going to be division now, and if I do that, there you go. My depth has to be 25.46479 centimeters. So if I let my height 25.46479 centimeters, I'll get very close to 2 liters or 2000 milliliters. Okay, Alright, but think about it. It's not so realistic to make the depth of the water bottle to be like to 25.46479 centimeters, right? It's hard to make it like that. So I made mine to be, I just got rid of all the decimals and let it be 25 centimeters high. So it's nice, easy number. Okay. Why didn't I go 26? Because if I make this 26, okay, the volume will exceed, it will go over to 2000. Right, so I have to get rid of all the decimals, and I made it down to 25 centimeters high or depth. So I explained it here. So I'll let my height or depth of the water bottle to be 25 centimeters. So all these numbers, you're making it up to make the volume 2000 milliliters. Okay, so I wrote it. Thus, my water bottle should contain, I'm talking about the volume, the base area 55 pi times the depth 25. So the volume of the water bottle that I designed should contain this much of water. You see that I changed my unit into milliliters because we're talking about the liquid of the water. Okay, you need to show us you need to draw the sketch. It doesn't have to be really 25 centimeters, but you need to draw me the sketch with all the values. Okay, so that's very important. Okay, so in order to get excellence, you should be able to tell me, right, how many sips you can drink from your water bottle that you designed, and how many milliliters of water will be remaining after taking certain amount of sips. Okay, so for example, my volume I already calculated to be 1963.5 milliliters of water. Okay, and in the question it says one sip would take 10 cubic centimeter, 10 milliliters per sip. Okay, so from the volume, if I divide it by 10, I can take 196.35 sips, right? That means if I take 196 sips, I'll be taking 1960 milliliters of water in total. And, right, taking off from there, entire volume, I will get 3.5 milliliters of water remaining in the water bottle. Okay, so this part is the excellence section. Okay, so if I give you another design, okay, you just need to do one, but I'm just showing you on an alternative answer. It could be like a heart shape or a star shape, triangular one, anything. You can design any water bottle that you want to design. Right, so this time I made it into a triangular prism shape water bottle. Okay, so I've said my base shape will be a triangle. Okay, and the dimension will be 13 by 13. I explained the base will be 13 and the height will be 13 as well. Again, think about the real size of the water bottle, whether it's realistic. Okay, if you let this like 2 centimeters by 4 centimeters, that's going to be like super tiny water bottle, and in order to contain 2000 milliliters of volume, okay, then it's going to be super tall. In that case, it's not a realistic design, right? So you cannot get an excellence if you set it like that. So think about the realistic design and start calculating. Okay, so here I calculated my base area of the water bottle. Base times height divided by 2 is how I find the area of the triangle, and that's the area of my triangle. Okay, now what I need to calculate is the depth. I don't know how much I should set my depth, so I'm going to show by using calculation. volume is area times the depth. Okay, my area I calculated to be 84.5. Depth I do not know yet, and that's going to be my volume. So sending 84.5 to the other side, and I'll get 23.6 centimeters. Okay. This means in order to make it very close to 2000 cubic centimeters volume, it should be 23.668639 centimeters high. But is it realistic to make it that detailed? Not really. So I wrote it like this, but it's not so realistic to make the depth or the height of the water bottle to be, indeed, in that detail, into that decimals, 4 to 5 decimals, right? So I'm gonna let my depth to be 23 centimeters, because if I round up and then make it 24, it's gonna exceed the 2000 milliliters. Okay, so I let it to be 23 centimeters. There you go. Like this, you need to sketch it, and you should be able to draw me with the labels of the measurement of the water bottle. Okay, now you have to calculate the volume. So base area of the triangle times the depth, it's a volume. I wrote it down as a cubic centimeter first because my unit was all in centimeter, right? And cubic centimeter is equivalent to milliliters, so I simply just change it into milliliters. There you go. And I said my water bottle should contain this much of water. Right, final one. In order to get excellence, you have to explain how many sips you can take and how much is remaining in the water bottle. So I can drink 194 sips in total, and I'll be drinking 1940 mils of water. Okay, how did I get that value? From the total volume. Each sip take about 10 cubic centimeters, so if I divided it, I can take 194.35 sips, but 0.35 sips is not even a one sip, so you take off the 0.35 sips and say I can take 194 sips, which is this much of water that I can take, and from there you minus this one, how much you take, that's the remaining, that's going to be remaining in the water bottle. Okay, so this is how you need to answer the task B. Okay, so have a go at designing alternative water bottles, okay? I hope you found this video helpful. Otherwise, I'll see you in the next lesson. Bye-bye.